Okay, so here are the 14-point part 1 notes. This is page 10. We are now going to talk about how to find the confidence interval, because we don't just guess at the margin of error, we have a reason for using the numbers that we do. Okay? So we're going to start with our point estimate. Again, we are talking about proportions. So our point estimate is p hat. Just a reminder, that is our sample proportion. And we find p hat right here by taking x, which is the number of times a success happens, and we divide that by n, which is the total number in our sample. It's our sample size. Okay. So to construct our confidence interval, our p hat goes right into the middle of our interval. So you notice we have our p hat right here. The plus part is going to give us the upper end of our confidence interval, and the minus part is going to give us our lower end. Okay, so some of this should look familiar. That square root of p hat times 1 minus p hat all over n, that's how we found the standard deviation for our proportion. We have z of alpha over 2, and this is new notation. We've seen those z-scores. We haven't really seen them with the subscores, and definitely not alpha over 2. Okay, so back up here a minute. Our confidence interval is p hat plus or minus our margin of error, which means that z of alpha over 2 times the square root shenanigans, that's our margin of error. So again, our margin of error is kind of our buffer around our point estimate. So we can acknowledge the fact that our point estimate came from a sample, and it may not be exactly like the population. Now, margin of error, sometimes E, right down here. Same one we have above. So let's talk about alpha and alpha over 2 and what this means in terms of what we know about the normal distribution. Okay? Suppose we have a p hat of 0.5. Okay? I could find the standard deviation if I knew the sample size. I don't. But keep in mind, when we standardize our normal distribution, we get a mean of 0 with a standard deviation of 1. Okay, so this 0 is holding the place for my p hat equals 0.5. And 85%, 86% confidence interval means I want to figure out how far I go out so that our area under the curve here is 0.86. Okay. Keeping in mind that our z-scores cut off the tails, the outside part, if I have 0.86 inside those two, I need 1 minus 0.86 outside those two z-scores. Okay. That 1 minus 0.86, that is our alpha. That tells me how much we want out on the tails. So 1 minus 0.86 is 0.14, sorry. And then alpha over 2 is 0.07. Now, why would I divide that by 2? If I want a confidence interval that wraps around my center, I am looking for how much is out in the tails. So if 0.86 is between my two lines here, 0.14 is outside, we divide that evenly between each end. My alpha over 2 is the area outside that z-score. Still need to find those z-scores. I have a probability and so I am going to use norm.s.inverse of 0.07. When I do that, I'm also going to move it over a little. I get a negative 1.4757. Again, we are rounding to two places for z-scores, so negative 1.48. That means this right here is my negative 1.48. Now, I could have done these using the 0.5 and the standard deviation. I would have to find the standard deviation. Not worried about that right now. So let's find the other z-score. Norm.s.inverse. This time I want 0.07 to the right, so 1 minus 0.07 gives me a 0.93. We know that this is symmetric. I get a positive 1.4757, rounded to two decimal places, gives me a 1.48. So 86%, or the area under the curve, is 0.86 between the negative 1.4, the z-score of negative 1.48 and the z-score of positive 1.48, which means outside on the tails is the 0.07 on each side. Okay, let's take a look at example 7 and do this again. We have First USA, a major credit card company, planning a new offer for their current cardholders. The offer will give double airline miles on purchases for the next 6 months if the cardholders go online and register for their offer. Nothing unusual. To test the effectiveness of the campaign, First USA recently sent out offers to a random sample of 50,000 cardholders. Of those, 1,184 registered. So let's start by taking a look at the information that we use. We've got 1,184 out of our sample of 50,000. So our p hat is our 1184 divided by 50,000, which gave us a return rate of 0.02368. Okay, now, because we want a confidence interval, I know up here in that gray, I need to find the standard deviation. So the standard deviation, sigma sub p hat, is going to be that 0.02368. And I will always calculate this separately and not within the formula. 1 minus that probability, that's where I am, the 1 minus p hat part, 0.97632. Divided by my sample size of 50,000. 0.00068. The next thing I need to do is figure out how I trap 95% of those card holders. So we want a 95% confidence interval. Which means I want the cutoffs here that give me 95% of the curve. So if I am trapping 95% between these two values, I can find my alpha, 1 minus 0.95. I have an alpha of 0.05. Okay, that alpha is important because I know if I've got 0.05 outside my two boundaries, then I've got an alpha over 2.025 in each of the tails. I can make that a little more readable. Now, I know what p hat is, I know what the standard deviation is, so I don't need to use norm.s.inverse. We're going to go with just the norm.inverse. For my lower bound, my lower end, let's see if we can color coordinate here. I've got a probability to the left of 0.025. I've got a mean of 0.02368, and I have a standard deviation of 0.00068. When I plug that into Excel, I get a lower bound here of 0.0223. Now, I am leaving it like that for places it's not a z-score because we need to answer another question and that percentage is going to be more helpful. Okay. So here is the lower bound of my confidence interval, 2.23%. I need to do the same thing. New color for my upper bound. I apologize for the non-complementary color use here. So again, equals norm.inverse. Now the area under the curve to the left is 0.975. That's 1 minus the 0.025. 0.025 is to the right. The 0.975 is what's left to the left. Same mean, 0.02368. Same standard deviation, 0.00068. When I plug that in to Excel, I could be smart about this, I get a value of 0.250. 0.0250. It's nice that I've made that super easy to read. It's not helping. There we go. Which means my upper bound is 2.50%. That is, so it matches up our 95% confidence interval. If the acceptance rate is only 2% or less, so we're going to answer B now, the campaign won't be worth the expense. Given the confidence interval you found, what would you advise? Well, our confidence interval ranges from 2.23 to 2.5%. Both of these ends are above their 2% threshold. So advise to move forward with the new offer. So our registrations should fall between 2.23% and 2.5%. Which is above the 2% threshold. One H. There's page 10.